numbers on a paper.
Hello dear friends, welcome to Humble Mark Academy. In this video guys, we shall be looking at the integral of the Lambert W function. Great. So friends, this is one of those very important functions we know in mathematics because it helps us to solve a wide variety of equations and some special functions guys, because there are some equations that look very impossible to solve, though we are very sure that we can have solutions. But solving those equations guys looks very difficult. But with the help of the Lambert W functions, we are able to evaluate a wide variety of such functions. So guys, before we get started, I would like us to introduce ourselves guys. I am Omenju Macarius. In this channel guys, I take complex science problems, the ones that students find it most difficult, the concepts that keep on killing students as far as the exams are concerned guys. I break them down into tiny pieces such that any science student across the world can use those concepts now to score a better mark in his or her exams. In exchange guys, I need your permission to help you pass those exams. I need your permission. By permitting me guys, you're just going to click on that subscribe button you see beneath this video. Click on the subscribe button guys, because that's a way in which you permit me to do what I need to do. Great. So guys, I want you to also give the video a thumbs up. That goes along with guys to motivate me to keep creating more great contents for you. Thank you very much guys. Let's dive straight into the video today. Great friends, great. All right, this is the question that we have guys, the integral of the Lambert W function, that's namely w of x dx. So guys, this our question looks somehow challenging, right? Because w of x is not like those normal functions that we know where we could just do integration by part and so on and so forth guys. Okay, it doesn't look like one of such. So guys, what do you think we can how do you think we can start by answering this question guys? What do you think? All right, so in this case guys, maybe we might want to transform this w of x into a function that we can easily recognize, right? So in this case guys, we are going to do a u sub. Okay, we'll do a u sub. We'll just let our u to be the w of x guys. Now guys, if you know how the Lambert W function behaves, you're going to understand the next step I'm about to write here. Okay, because in this case guys, it therefore means that our x is the same like what? U times e raised to the power u. Okay, because if you just take w on both sides, the output of the right hand side will simply be what? U, which is what we have here. Then we have w of x. Okay, that's it guys. Such that in this case now we need a dx. We differentiate both sides. That therefore implies dx. Applying the product rule here guys, because we have a product of two functions. We differentiate the first, that is differentiating u in the u world, which is going to be 1. Keep e raised to the power u constant. Plus now we keep u constant and differentiate e raised to the power u, which still gives us e raised to the power u since it never dies, du. Wait, that therefore implies guys, this our function now can simply translate into now the integral of our w of x is what guys? Our u, right? So we have the u here. Then dx is what guys? Is just e raised to the power u plus u e raised to the power u du. Great. That therefore implies in this case guys, if we decide to factor out an e raised to the power x as an e raised to the power u, we are going to have the integral of, we have u multiplies, that we factor out e raised to the power u, we are going to have u plus u squared into e raised to the power u du. Great. So in this case guys, we need to evaluate this integral guys, and from the look of things, one way you can do is that you can multiply e raised to the power x on both, e raised to the power u on both sides, then split the integral into 2. But friends, that is going to take more time. Okay, why don't we look at the function in yellow as the one part of the function that we're going to differentiate and integrate e raised to the power u. So guys, our reason for differentiating u plus u squared is that when we differentiate u plus u squared du in the u world, we are going to see that it is going to die down to 0. Okay, because we differentiate u, we are going to have 1. Differentiate again, we are going to have 0. Same as for u squared. Differentiating u squared one time, we have 2u. Again we have 2. Again we have 0. It can die down to 0. Then meanwhile, integrating e raised to the power u about a million times guys, it never dies. So in this case guys, we are going to do integration by parts, and we are going to do that using the di method. Great. So we are going to have our d and the I. The signs alternate from positive, negative, positive, and negative. If we need more rows guys, we continue in this same pattern. So like I said, guys, we are going to differentiate u plus u squared, and we integrate e raised to the power u, great, as you have it here. So this is u plus u squared, this is e raised to the power u. Alright guys, if we differentiate u plus u squared in the u world, differentiating u, guys, gives us 1. Differentiating u squared gives us 2u. So we have 1 plus 2u. Then guys, in differentiating it again, if we differentiate 1, we have 0. Differentiate 2u, we are going to have just 2. Great. So we have just 2. We differentiate the 2 again, guys, we are going to have 0. Great. We love to see zeros. Okay, we love to see zeros. So in this case, integrating e raised to the power u about 10 million times, guys, you're also going to have the same e raised to the power u. So we just fill everything here with e raised to the power u. Great. So now, guys, by the integration by part method, or by the DI method, the integral of u plus u squared times e raised to the power u du simply becomes, we are going to multiply these diagonals, okay? The product of these diagonals are just going to give us our answers, okay? They give us our answers. So we're just going to have u plus u squared times e raised to the power u. Then multiply this other diagonal, guys, this other guy, and this negative here. Take note, so we are going to have negative 1 plus 2u into e raised to the power u. Great. Then, guys, multiply this, the last diagonal, we are going to have positive 2 times e raised to the power u. Great. That's what we have, friends. Keep in mind that under number circumstance, if here was not 0, right, if here was something different from 0, like we are going to multiply 0 and e raised to the power u and still put it inside of the integral. Great. But since here is 0, guys, integrating and 0 times e raised to the power u is still 0. Integrating 0 simply gives us a constant. The constant is going to come at the end. Okay, great. So now, guys, by so doing, we are going to have the integral of u plus u squared e raised to the power u du simply becomes u plus u squared into e raised to the power u minus 1 plus 2u into e raised to the power u plus 2 e raised to the power u. Great. So guys, if we open all the brackets, we are going to have the integral of u plus u squared e raised to the power u du to be the same like multiplying e raised to the power u inside. We are going to have u e raised to the power u plus u squared e raised to the power u minus e raised to the power u now minus 2u e raised to the power u plus these 2 e raised to the power u here that we have. So guys, we have u e raised to the power u right there. We have minus 2u e raised to the power u. So you can give us negative u e raised to the power u. So guys, if we simplify everything and bring forth like terms, we are going to have this integral translating into just u squared e raised to the power u minus u e raised to the power u plus e raised to the power u. Great. So now, guys, that therefore implies now the integral of the Lambert W function, that is w of x, is just the same as, we are going to replace all the u's now back with its value, which is what, guys? W of x. Great. So we are now going to have u squared, which is w of x, all that squared. So we are going to have w squared of x, then e raised to the power, our u is w of x, so we have it plus w of x, e raised to the power w of x plus e raised to the power w of x. Great. So now, guys, we can therefore conclude that the integral of the Lambert W function simply becomes, if we factor out our e raised to the power w of x, since we have it on both sides, then now we put our constant of integration, the constant, we are going to have w squared of x plus w of x plus 1, all that times e raised to the power w of x plus c. Great. So guys, I hope you found the video so useful, guys. If you found it useful, a simple thumbs up will go a very long way, guys, and subscribe to Humble Mark Academy for more videos. Great. Thank you so much, guys, and have a blessed day.